Hello, my name is Joya De Lagon, and today I want to talk a little bit about contest and then connect it to my area of interest. So, firstly, large language models are rapidly growing in popularities, and with their growing in popularity, that leads to them being used in real life systems. And them being used in real life systems mean that they're used in critical systems. And that leads to people and researchers and programmers having concerns regarding the reliability of large language models. However, the current testing available doesn't really focus on the knowledge gaps or inconsistencies in LLM. There isn't much testing methods available in that regard. And that brings me to Contest. Contest is an automated testing framework that finds inconsistencies in large language models. It does this by extracting the relationships between entities using knowledge graphs and generating yes or no test cases to identify inconsistencies in the large language models. Contest was used in the paper to find the knowledge gaps and inconsistencies in four large language models. These included Falcon, Gemini, ChatGPT 3.5, and Llama 2. And overall, the paper proposed model ensembling, which would be the combination of multiple LLMs, as a way to improve the LLM reliability. And that brings me to the next part, the knowledge gaps. The main knowledge gaps I found with Contest includes the fact that Context works mainly with yes or no queries, which is good, but in the real world, when people are using large language models, the large language models usually respond with larger responses than just yes or no. Another one is that Context relies on only one source for its knowledge graphs, which is Wikidata, which is okay, but it would be much better if we used multiple sources, I feel, so that we can be sure that the source we're using is very accurate. Another thing is with the knowledge graphs, Wikidata is frequently being updated, so you would have to frequently update the knowledge graphs. Um, Another one is that Context is only tested on places and music, specifically places in the highest GDP country, which typically includes more popular or more frequently talked about countries online like America and China, etc. Yes. So that brings me to my research area, Beyond YN, which is beyond yes or no, knowledge-based consistency testing of large language models. So, what is my research area? I would like to implement NLP classification, natural language processing classification, to detect affirmative and non-affirmative responses using semantic similarity models. So, for instance, if the large language model replies with a longer text, the NLP classification can decide whether it's affirmative, non-affirmative, or maybe the large language model is unsure, which I think models real life applications and real life responses more. Another one is I would like to implement more sources for us to allow context to use. I feel like that will provide a more credible source. Um, and I also want to test contest using multiple fields. And for this whole thing, I want to have a comparative study to see how my interventionist approach improves context or doesn't improve. Hopefully, it improves it. So I'm going to go about it by having a baseline assessment. So I measure contest's current level, how accurate context is with the current data set. So that's with Wikidata, and just overall how it's doing. And then afterwards, I'll have the algorithm development. So I'll implement the query classification. This is basically so that context can work with longer sentence. I'll generate test cases for different fields, not just places and music. And I'll implement a cross-checking algorithm that verifies the facts across multiple databases. So we're not just using Wikidata. And then in the end line, I will obviously compare context accuracy with the cross-evaluation data sets to the one we had at the baseline. And I also want to test the algorithm in new fields, and obviously fields that are less frequently discussed online. And that brings me to my research questions. My first research question would be, how does using an NLP classifier increases context ability to understand and generate test queries? Because I noticed we had to remove a few queries because they weren't strictly yes or no answers. So I think this will give a more accurate response. It will be a more accurate measure of how consistent these LLMs are, because it won't just remove data that's not automatically yes or no. How does using multiple knowledge sources improve a knowledge graph's accuracy? So in this way, we aren't just testing the LLMs, but we're testing context itself and seeing how good it itself is at even testing whether these research gaps are there or not. And finally, can context effectively adapt to new knowledge area while maintaining consistency? So we're going to test it in different fields of study and see if context is still as good as it would be in other fields that we've already looked at. And so the metrics I will be using for this include consistency rate. So that means I'm going to measure the percentage of inconsistencies in the system. The next one is precision and call. And for precision, I want to measure how accurate context is when it decides whether an LLM's response is consistent or not. And the next one is recall, which is I want to check how many actual inconsistencies context catches. So the first one is context is deciding, okay, this is correct or not correct. And then the next one is how many it catches. And that leads me to F1. And F1 is a balance between precision and recall, because you could argue that if it's very precise, it might say some answers are wrong that are not wrong. No, if it's F1 is a balance between the two, because with precision, it's going to select certain ones and it might remove ones that it's worried might not be correct, while recall is how many inconsistencies it catches actually. So they kind of are against each other but together at the same time. Another one is the error reduction rate. So I want to see how implementing multiple sources could perhaps maybe reduce the false positives or false negatives. Domain adaptability score. So I want to check the performance in different fields. An ability of NLM to categorize LLM's responses. So that's seeing how good our NLP classifier is. And that brings me to the expected results. For the expected result, I think the first one is improve in consistency detection due to NLP test queries. So I want to ensure that obviously the implementation of natural language processing improves the context. The next one is improvement in factual accuracy due to the use of multiple knowledge graphs. So hopefully I think that by using multiple sources, context will be able to will be more credible because it's using multiple sources and it's not just relying on one. It will use a similar approach to the one proposed in the papers for LLMs. So we'll have a weighted method where we would pick the most credible answer. And the last one is how good it is in various domains. So we'll compare, so hopefully it will be better at other domains that are less discussed on the internet or are less popular in general. Thank you.